Hi there. For this video, we'll be showing some additional examples on applying the binomial theorem, since I felt like the examples in the previous video was not enough. And so let's write binomial theorem now. Theorem. Now, to recall, we first recall that the formula or the binomial theorem states that x plus y raised to n is equal to the summation from k equals 0 up until n of n choose k times x raised to n minus k times y raised to k. So we'll take note of this one. So let's minimize this first and put it out here. And so let's go on with our first example. Let's have a plus 2 raised to 4. To solve this, applying the binomial theorem, we have summation from k equals 0 to 4 of 4 choose k and a raised to 4 minus k times 2 raised to k. So solving this one, first at k equals 0 we have 4 choose 0 times a raised to 4 times 2 raised to 0 plus 4 choose 1, this now in k equals 1, times a raised to 4 minus 1 is 3 times 2 raised to 1 plus 4 choose 2 of a raised to 4 minus 2 is 2 times 2 raised to 2 plus 4 choose 3 of a raised to 4 minus 3, which is 1 times 2 raised to 3. And lastly, we have 4 choose 4 of a raised to 4 minus 4 is 0 times 2 raised to 4. Now, the first thing that we can simplify is recall that when a number or a variable is raised by 0, like this one and this one, this simply is equal to 1. So we can remove this one and this one to clear out some space. Now, furthermore, we can also simplify the 2's out here, the power of 2's. So first, note that 2 raised to 1 is simply 2. So we can remove the exponent out here. 2 squared will result to 4. 2 cubed will result to 8. And 2 raised to 4 will result to 16. Now from here, we can now dive into the combination. This, and this. Now, a useful theorem that we can use out here is that, note that n choose r is equal to n choose n minus r. So in our given, we know that 4 choose 0 is equal to 4 choose 4. 4 choose 1 is equal to 4 choose 3. So we simply need to focus on this first 3, since 4 choose 3 can be obtained by getting this one, and 4 choose 4 can be obtained from getting this one. So let's focus first on 4 choose 4. This will result into 4 factorial over 0 factorial times 4 minus 0 factorial, which simplifies into 4 factorial over 4 factorial, or simply 1. So this one out here becomes 1, and this one out here becomes 1. Next, 4 choose 1. So this will be 4 factorial over 1 factorial times 4 minus 1 factorial, which will result into 4 factorial over 3 factorial, which can be written as 4 times 3 factorial over 3 factorial. Cancelling out the 3 factorial, we obtain 4. So 4 choose 1 is equal to 4, and 4 choose 3 is equal to 4. Now, as an exercise, you can verify that 4 choose 2 is equal to 60. So let's write this one, exercise. And so, yeah. This one, oops, apologies, it should be 6. Yeah, my bad. This one simplifies into 6. And so we have a raised to 4 plus 4a cubed times 2, or simply 8a cubed plus this one in the middle is 6 times 4 times a squared, which is 24a squared plus 4 times 8 times a raised to 1, or simply 32a, and the last term is 60. And so this is the answer for this example. Let's move on to our next and final example. Let's have 1 minus b squared raised to 5. Now for this one, we'll try to tackle this example since we haven't really encountered an example with a minus 1. Now the trick here is to write this one as 1 plus negative b squared. And from here we can already apply the binomial theorem. So we'll have the summation from k equals 0 to this time 5 is 5 choose k times 1 raised to 5 minus k times negative b. Oops. The square should be inside. Right there. Negative b squared raised to k Yep, that one. And observe here that we can actually simplify this even more, since 1 raised to any exponent will simply be equal to 1. So we can remove that one, and so we'll have the summation from 0 rather to 5 of 5 choose k is simply negative b squared raised to k. Furthermore, we can simplify this one, since we can split negative b squared into negative 1 times b squared raised to k. And observe that by applying laws of exponents, we can distribute k out here to obtain summation 5 k equals 0 out here. So let's fix the 0 of 5 choose k, and this one out here will be negative 1 raised to k times b squared raised to k, or simply times b raised to 2k. And this one is much easier to evaluate. So let's clear out some space. Now, since there isn't much space out here, I will just try to write out the outline of this solution and this one. So this will result into, let's use a thinner pen. This will result into 5 choose 0 of negative 1 raised to 0 times b squared times 0 plus 5 choose 1 times negative 1 raised to 1 times b raised to 2 times 1 plus 5 choose 2 negative 1 squared times b raised to 2 times 2 plus 5 choose 3 of negative 1 cubed times b raised to 2 times 3 plus 5 choose 4 times negative 1 raised to 4 times b raised to 2 times 4, and lastly 5 choose 5 times negative 1 raised to 5 times b raised to 2 times 5. Now out here, notice that this 2 would simply simplify into 1, since they both have an exponent of 0. So we can remove that one out. Let's move this one. And also, note that we can simplify the exponents out here, since they are just multiples of 2. So we'll have first here a square, and this one will be raised to 4. This one will be raised to 6. This one will be raised to 8. And this one out here will be raised to 10. Now also, focusing on this powers of negative 1, note that negative 1 raised to an odd number, say n is odd, the outcome is negative 1. But if we raise it to, say, negative 1, raised to k, where k is even, this will become 1. So with this in mind, this first negative here becomes times -1. The second one here becomes 1. The third here becomes -1. The fourth here becomes 1. And the fifth here becomes -1. Now, the only one left is these combinations out here. But I'll leave that to you to verify that this will be equal to 1. This will be equal to 1 as well. This will be equal to 5. And this 2 will be equal to 10. So with all that said, the final answer for this one will be 1 minus 5b squared plus 10b raised to 4 minus 10b raised to 6 plus 5b raised to 8 minus b raised to 10. And this is the final answer. So yeah, I hope you learned something from this video. Although we tackled just 2 examples, since the solution is kinda long and hard, I hope that you can practice these examples on your own, as this will be really helpful and a great practice on your skills in summations, combinations, multiplications of algebra, and so on. And so yeah, that's it, and that is all for this video.